Friends, welcome to the class. Today we'll discuss about some questions on coordinate geometry. Friends, you will come across some questions which already appeared in previous board exams. So these questions will be very much helpful from the exam point of view. So let's start. The first question states, find the radius of the circle whose end points of diameter are 24,1 and 2,23. Let the diameter of the circle be PQ such that P 24,1 and Q 2,23. We know that the distance between any two points, say P x1, y1 and Q x2, y2 is given by PQ equals to x2 minus x1 whole square plus y2 minus y1 whole square whole root over. So we can write PQ equals to 2 minus 24 whole square plus 1 minus 23 whole square whole root over, or it is nothing but 22 square plus 22 square whole root over. This implies PQ equals to 22 root 2. But what is PQ? PQ is diameter and radius is nothing but diameter by 2. So we can say radius equals to 22 by 22 root 2 by 2, which is nothing but 11 root 2 unit. Hence, the radius of the circle is 11 root 2 unit. Is the answer. Prove that the points 3, 0, 6, 4 and minus 1, 3 are the vertices of a right angle isosceles triangle. First of all, we need to verify whether these 3 points constitute a triangle or not. How it can be done? We have to find out the individual distance of these 3 points from each other. If sum of any two distance is greater than the third one, that means the distance will represent the sides of the triangle. If sum of any two sides is greater than the third one, then only we can say these 3 points constitute the vertices of a triangle. And afterwards, if the sides justify the Pythagoras theorem, then we can say they constitute a right angle triangle. Let's go for it. Let the vertices of the triangle are A 3, 0, B 6, 4 and C minus 1, 3. Now we know that the distance between any two points, say A x1, y1 and B x2, y2 is given by x2 minus x1 whole square plus y2 minus y1 whole square whole root over, or it is nothing but AB equals to 6 minus 3 whole square plus 4 minus 0 whole square whole root over, which is 5 unit. Likewise, BC equals to minus 1 minus x whole square plus 3 minus 4 whole square whole root over, which is equals to 5 root 2 unit, and CA equal to 3 plus 1 whole square plus 0 minus 3 whole square. This is also equals to 5 units. So here we got AB and AC both are of the same unit, that is 5 unit, and BC is 5 root 2 unit. But the sum of any two sides, that is AB plus BC or BC plus CA or CA plus AB, is greater than the third one. So here AB equals to AC, so triangle ABC is an isosceles triangle. Now AB square plus AC square equal to 5 square plus 5 square equals to 50, which is equals to BC square, because BC is 5 root 2 and BC square is 5 root 2 whole square, which is nothing but 50. That means it satisfies the Pythagoras theorem. So you can say triangle ABC is right angle at angle A. Hence triangle ABC is a right angle isosceles triangle. Hence proved. Point P divides the line segment joining the point E2, 1 and B5, minus 8 such that AP by AB equals to 1 by 3. If P lies on the line 2x minus y plus k equals to 0, find the value of k. So here is the picture. Given that P divides line AB in the ratio AP by AB equals to 1 by 3, or we can write it as, what is AB? AB is nothing but AP plus BP. So we can write AP by AP plus BP equals to 1 by 1 plus 2, or it is nothing but AP by BP equals to 1 by 2. That means point P divides AB in the ratio 1:2. Now, using the internal section formula, the coordinates of P can be written as m1x2 plus m2x1 by m1 plus m2, comma m1y2 plus m2y1 by m1 plus m2. So Px, y can be written as 1 into 5 plus 2 into 2 whole divided by 1 plus 2, comma 1 into minus 8 plus 2 into 1 whole divided by 1 plus 2, which is nothing but 3, minus 2. Now it is given that P lies on the line 2x minus y plus k equals to 0. So the point that we obtained 3, minus 2 must satisfy the equation 2x minus y plus k equals to 0. Then only we can say that P lies on this particular straight line. Let's check that one. So 2 into minus 3 minus of minus 2 plus k equals to 0, or this implies 8 plus k equals to 0, or k equals to minus 8. Hence, the value of k is minus 8 is the answer. If a minus 2 comma 1, b a comma 0, c 4 comma b, and d 1 comma 2 are the vertices of a parallelogram ABCD, find the values of a and b. Also find the length of the sides. Now given that a minus 2 comma 1, b a comma 0, c 4 comma b, and d 1 comma 2 are the vertices of parallelogram ABCD. Now we know that the midpoint of p x1 comma y1 and q x2 comma y2 is given by x1 plus x2 whole divided by 2 comma y1 plus y2 whole divided by 2. So the midpoint of the diagonal AC is nothing but minus 2 plus 4 whole divided by 2 comma 1 plus b whole divided by 2, or it is nothing but 1 comma 1 plus b by 2, and the midpoint of the diagonal BD is a plus 1 whole divided by 2 comma 0 plus 2 whole divided by 2, or it is nothing but a plus 1 by 2 comma 1. Now we know that the diagonals of the parallelogram bisect each other. That means both AC and BD have the same midpoint. So we can write 1 comma 1 plus b whole divided by 2 equals to a plus 1 by 2 comma 1, or on equating the x coordinates and y coordinates we get 1 equals to a plus 1 whole divided by 2 and 1 plus b by 2 equals to 1, or this implies 2 equals to a plus 1 and 1 plus b equals to 2. That means a equals to 1 and b equals to 1. So now we got the coordinates. So the coordinates of the vertices of the parallelogram are a minus 2 comma 1, b 1 comma 0, c 4 comma 1, and d 1 comma 2. Now distance between any two points with the coordinates x1 comma y1 and x2 comma y2 is given by x2 minus x1 whole square plus y2 minus y1 whole square whole root over. So AB, that means distance between A and B, is minus 2 minus 1 whole square plus 1 minus 0 whole square whole root over, which is root 10. BC equals to 1 minus 4 whole square plus 0 minus 1 whole square whole root over, which is also equals to root 10. CD equals to 4 minus 1 whole square plus 1 minus 2 whole square whole root over, which is again root 10. And DA 1 plus 2 whole square plus 2 minus 1 whole square whole root over, which is root 10. Hence, the values of A and B are 1 each, and the length of the sides of the parallelogram is root 10 unit each. Find the area of a parallelogram ABCD if three vertices are A2, 4, B2 plus root 3, 5, and C2, 6. So here in the parallelogram ABCD, only three vertices are given: A2, 4, B2 plus root 3, 5, and C2, 6. We know that the area of quadrilateral ABCD is twice of area of triangle ABC. So area of triangle with vertices x1, y1, x2, y2, and x3, y3 is given by 1 by 2 determinant of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. Now area of triangle area of triangle ABC equals to 1 by 2 determinant of 2 into 5 minus 6 plus 2 root 3 4 into 6 minus 4 plus 2 into 4 minus 5, or it is nothing but 1 by 2 4 into 2 into minus 1 plus 2 plus root 3 whole into minus 2 plus 2 into minus 1, that is root 3 unit. So the area of the parallelogram is twice of root 3 or 2 root 3 unit. Hence the area of the parallelogram is 2 root 3 unit is the answer. The next question is, if area of triangle ABC formed by AX, Y, B1, 2 and C2, 1 is 6 square unit, prove that x plus y equals to 15 or x plus y plus 9 equals to 0. Given the coordinates of the vertices of triangle ABC is AX, Y, B1, 2 and C2, 1, and area of the triangle ABC is 6 unit. Now we know area of triangle ABC is given by 1 by 2 determinant of x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So So it can be written as 1 by 2 whole into x into 2 minus 1 plus 1 into 1 minus y plus 2 into y minus 2 equals to 6. Or this implies determinant of x plus 1 minus y plus 2y minus 4 equals to 6 into 2, or determinant of x plus y minus 3 equals to 12. So when you remove the determinant, we get x plus y minus 3 equals to plus or minus 12. So it has two outcomes. Either x plus y minus 3 equals to minus 12 or x plus y minus 3 equals to 12. That means we can write it as x plus y minus 3 plus 12 equals to 0, or x plus y equals to 12 plus 3. This implies x plus y plus 9 equals to 0, or x plus y minus x plus y equals to 15. Hence proved. If the centroid of the triangle formed by the points a, b, a, b, b, c, and c, a is at the origin, find the values of a square by ab plus b square by ac plus c square by ab. So the vertices of the triangle are given, that is a, b, b, c, and c, a, and the centroid is origin. That means the coordinates of the centroid is 0, 0. Now we know that the centroid of any triangle with vertices x1, y1, x2, y2, and x3, y3 is given by x1 plus x2 plus x3 whole divided by 3, y1 plus y2 plus y3 whole divided by 3. So the centroid of the given triangle can be written as a plus b plus c whole divided by 3, c plus b plus a whole divided by 3. And this is equals to 0, 0, because the coordinates of the centroid is 0, 0, or this implies a plus b plus c equals to 0. Now a square by bc plus b square by ac plus c square by ab is a cube plus b cube plus c cube whole divided by abc, because if we take abc in LCM, in the numerator we get a cube plus b cube plus c cube, but a cube plus b cube plus c cube equals to 3abc when a plus b plus c equals to 0. Already we got a plus b plus c equals to 0. So a cube plus b cube plus c cube can be written as 3abc by abc. So abc and abc in both numerator and denominator gets cancelled, and we get the result to be 3. So the answer is 3. In the given picture, two friends, Seema and Aditya, work in the same office at town C. During vacation, they decided to go to their hometown, represented by town A and town B respectively. So here is the picture. Now, the first question is, who will travel more distance, Seema or Aditya, to reach their hometown? The second one, they decided to meet at a location represented by the midpoint of the line joining town A and B. Find the coordinates of the point D. And the third one, find the area of the triangle formed by joining the points represented by A, B, and C. So given the coordinates of the points A 2, 6, B 5, 2, and C minus 5, 4. So we know that the distance traveled by Seema is CA and the distance traveled by Aditya is CB. Now CA equals to 5 minus 5 minus 2 whole square plus 4 minus 6 whole square whole root over, or this is equals to minus 7 whole square plus minus 2 whole square whole root over, which is nothing but 53 unit, square root of 53 unit. And CB equals to minus 5 whole square plus 4 minus 2 whole square whole root over, which is nothing but square root of 104 unit. That means CB is greater than CA. So Aditya traveled more distance. Now in the second bit, D is the midpoint of the town AB. Now using D midpoint formula, we get coordinates of D is 2 plus 5 by 2, 6 plus 2 by 2, which is nothing but 7 by 2, 4. The third one is area of triangle ABC. Area of triangle ABC can be given as 1 by 2 determinant of 2 into 2 minus 4 plus 5 into 4 minus 6 plus minus 5 into 6 minus 2, or it is nothing but 1 by 2 determinant of minus 4 minus 10 minus 20, or it is determinant of minus 34. That means it is 1 by 2 into 34, which is 17 square unit, is the answer. A 6, 1, B 8, 2, and C 9, 4 are the three vertices of a parallelogram ABCD. if E is the midpoint of DC, find the area of triangle ADE. Let's draw the picture. So here three vertices are given. Three vertices of parallelogram ABCD is given, that is A 6,1, B 8,2 and C 9,4. And also it is given that E is the midpoint of DC. So before we go for that, let the fourth vertex of the parallelogram D be x, y. Now we know the diagonals of the parallelogram bisect each other. That means the coordinates of the midpoint of AC equals to coordinates of the midpoint of BD. Now coordinates of midpoint of AC is 8 plus x whole divided by 2, 2 plus y whole divided by 2, and that of BD is 6 plus 9 whole divided by 2, 1 plus 4 whole divided by 2, or we can write it as 8 plus x whole divided by 2, 2 plus y whole divided by 2 equals to 15 by 2, 5 by 2. Now equating the coordinates, respective coordinates, that we get 8 plus x by 2 equals to 15 by 2 and 2 plus y by 2 equals to 5 by 2, or this implies x equals to 7 and y equals to 3. So we got the coordinates of the point D. The coordinates of the point vertex D is 7, 3. Now the E is the midpoint of CD. So the midpoint of E can be written as 7 plus 9 by 2, 3 plus 4 by 2, or E, the coordinates of E is 8, 7 by 2. Now the triangle ADE, the area of triangle ADE can be written as 1 by 2 determinant of 6 into 3 minus 7 by 2 plus 7 into 7 by 2 minus 1 plus 8 into 1 minus 3, or it is nothing but 3 by 4 square unit is the answer. Hence the area of triangle ADE is 3 by 4 square unit. The coordinates of A, B and C are 7, 4, minus 2, 6 and 5, minus 1 respectively. P is any point with coordinates x, y, so that the ratio of triangle ABC and triangle PBC is determinant of x plus y minus 4 whole divided by 7. So here the 4 points are given, A, B, C and the point P. And the coordinates of point ABC is known to us and that of P is not known to us. So let's draw the picture. The picture is like this. Given the coordinates of the vertices of triangle ABC is A 7, 4, B minus 2, 6 and C 5, minus 1, and P is any point with coordinates P, x, y. Now area of triangle ABC is 1 by 2 determinant of 7 into 6 plus 1 plus minus 2 into minus 1 minus 4 plus 5 into 4 minus 6, or it is nothing but 1 by 2 whole into 49 plus 10 minus 10, which is nothing but 49 by 2 unit. Now area of triangle PBC is 1 by 2 determinant of x into 6 plus 1 plus minus 2 into minus 1 minus y plus 5 into y minus 6, or it is nothing but 1 by 2 determinant of 7x plus 2 into 1 minus y plus 5 into y minus 6, which is nothing but 1 by 2 7x plus 7y minus 28, or we can write it as 7 by 2 determinant of x plus y minus 4. Now area of triangle PBC by area of triangle ABC equals to 7 by 2 determinant of x plus y minus 4 whole divided by 49 by 2. So in both numerator and denominator 2 gets cancelled, or we get it is x plus y minus 4 whole divided by 7. Hence proved. Friends, here is a few questions. Practice more and more such questions. And in case you come across any difficult question, feel free to share your question with me. It will be a pleasure for me if I can help you out in solving your questions, in solving your doubts. So this much for today's class. Thank you.